This video is from 2016, apparently before I knew how to focus a camera, but bear with me, it does clear up. I was commissioned to modify an existing dance prop that I had made, which was two interlocking spheres that spun on its axis. And what they wanted to do is add a trapeze that hung from the top of this. That spun freely of this orb, essentially. And so I had to devise a way to roll 1.5-inch solid round stainless steel rod into a 30-inch diameter ring. I decided to use 1.5-inch round for its ergonomic shape. I knew it would be easy to hold on to. We went with solid round for two reasons. One was the inertia that it would give us, and two, the reduction in deformation over a hollow shape when working with it. I designed this form roller to be lever operated in a simple mandrel idler setup. The mandrel is a wheel from a trackmobile that are used to move train cars around, so essentially a train wheel. Trackmobile wheels are forged, so this is a forged piece of steel. I'd estimate it's around 400 pounds. Took a lot to move around. We actually ended up cracking the brake rotor that we were using to mount it to the hub. Right there, just flopping it back and forth. That's all it took to crack a cast steel rotor. Sticking with the simplicity of the machine, we just used the front end hub assemblies and the brakes off of a old Pontiac G6 to make the idler roll and mount the mandrel roll straight to the fab table. You can see here we're welding that straight to the fab table. We ended up anchoring that table to the posts on the pole barn as well. We didn't want it to move. Here we broke out the chain falls to pick up the train wheel and set it on that hub. It was giving our trusses something to groan about there. But it's right here that we noticed the crack in the hub, and going back and forth, we just decided to roll with it, throw some weld in there, clean it up as much as we could. Worst case, it just pops and drops. So we ran with it. For the lever, we used some 3x3 angle. I think it was something like 3/8 inch thick. Then we welded in a 2-inch schedule 40 piece of pipe, and then inside of that we used a stick of 2-inch solid round, and we could extend this out. We actually ended up maxing out by the garage door opening there, something like 16 feet of lever. And we fastened it with a kind of a ratcheting, quote unquote, action by using the lug holes, just like you can see there. This is about 1,600 foot-pounds of torque needed to be applied to get into plastic deformation. Now, one thing that we kind of just were going to solve as it came up was how do we go past our start point there. As you can see, we cut it off. It ended up being a little bit of a mistake or short-sightedness. I addressed this egg shape from having to cut and restart by making a form on the table and heating the rod up until red hot, and clamping it into place. This also took the little twist out of there. Really enabled us to rein it in and get a really good looking piece. After getting that all straightened out, mounted it to this roller bearing setup. I believe it was tapered. And had it machined down, fit on a shaft, and made a housing and welded that right into the sphere. The project was successful in that I learned a lot and the client was happy. So thanks for watching.